Hello, this is Eric White with the next episode in this screencast series on writing recursive pure functional transformations of XML. In the first screencast in this series, we talked about the identity transform. And in the screencast just before this one, we talked about replacing an element with a different element. And to show that scenario, I transformed a little bit of word processing ML into HTML. And in this screencast, I'm going to show how you remove elements, how you take care of this particular scenario in doing recursive pure functional transformations. In the previous screencast, where I was transforming word processing ML to HTML, it was a document-centric transform from one vocabulary to a different vocabulary. In other words, it was transforming from word processing ML to HTML. If you recall back when I talked about document-centric transforms, I talked about that there are two varieties of such transforms. You can transform from one vocabulary to a different vocabulary, like we did in the last screencast, or you can transform from a vocabulary to another document in the same vocabulary, and that's what we're going to do today. The example that we're going to take today is that we're going to take a word processing document that has proofing errors in the document, and we're going to remove those proofing errors. And in the process of removing those proofing errors, we're going to start with a valid word processing ML document, and we're going to end up with a valid word processing ML document just without those proofing errors. So the first thing that I'm going to do in this screencast is I'm going to review the semantics of linked XML that enable this particular aspect of a transformation. In other words, enabling removing an element in the process of doing a transformation. So here we have a little linked XML program. It creates an X-element root with two X-element children elements, each named child. And if we run it, we see what we expected to see. The aspect of the linked XML API that enables us to remove elements when we're transforming is that we can pass in null to the X-element constructor. So here, if I alter this program and I pass in null as one of the arguments to that X-element constructor and I run it, I get the exact same results. That linked XML sees the null and simply ignores it. And this is an intentional part of the semantics of linked XML for this very reason. So now let's set up an OpenXML application here. I'm going to add my references. I'm going to add document format.openxml, and I'm going to add Windows base. I'm going to come up here and add a using document format.openxml.packaging. Now, if we go back and look at the folder, I've copied in these two files, pt-openxmlutil.cs and pt-util.cs. I like having those files around. They're pretty useful to me. I like to use some of the functionality in there. It makes my life a whole lot easier. So I am going to add those existing items to my project. And I'll have to add a using for the OpenXML Power Tools. I had initially set this value to false, but actually we want to set that value to true because we are going to write into this document. We're going to open up test.docx and we're going to remove all of the proofing errors in that document. I'll use this getXDocument method. That's part of the OpenXML Power Tools. I will set this variable new root to the results of a method remove proofing transform. I'd better have a cast in there to X-element because that method returns an object, as all of these transforms do. Now I'll finish out this function and then I'll go write that transform. To finish out this function, I'll say xdoc.root.replace with new root. Then I will put the X document back into the main document part. And that's all we have to do in this method. At this point in time, when we finish the program, that main document part will be written back into the actual document. So now let's go write our remove proofing transform method. I'll right-click on there and tell it I want to generate a method stub for this. I'm going to change this method stub a little bit. I'm going to make it return an object, not an X element. And instead of having it take an X element, I want it to take an X node. And I will, first of all, put in the identity transform. Now we have our identity transform. And then we're going to create a document that has some proofing errors in there. I'll put this document right into my bin debug directory so that we can open it in as easy a fashion as possible. I'll call it test.docx, and I'll put in, this is an example of a document that contains proofing errors. A common place where you have proofing errors is if you include C# code in a Word document. Word doesn't really understand that we don't really want proofing errors for all of these symbols in this C# code. Now we could go into this document and we could tell Word to not show proofing errors, but then that would not show proofing errors for the entire document. But we can just selectively go in and remove these particular proofing errors. I'll show you how we're going to do that. Let's save test.docx and exit. I'm going to examine this document in the OpenXML Package Editor Power Tool for Visual Studio 2010. I'll drag test.docx onto Visual Studio. I'll open up the main document part and format the XML. Now I'm going to look for proof, and here we can see this element proof error. And we can see it has a type of gram start and another proof error of type of gram end. In other words, a proofing error for grammar and the start and end. We can just remove all of these. So that's what we're going to remove in our transform. So here I'm going to say if element.name is equal to w.proofError, return null. And that's all I have to do. This is going to remove all proofing errors wherever they occur in that document. Before I run the example, I'm going to copy and paste test.docx because we're going to go modify that one, and I'm going to want to run this a couple of times and show you a couple of different aspects of doing this transform. So we run it and it runs successfully, and let's go look at the results. And sure enough, we have removed all of those proofing errors. Now, I could have selectively removed those proofing errors based on the style of the paragraph or what have you. I'll leave that as an exercise for you in your particular transforms if you want to try that out. So let's go look at the markup. And we can, sure enough, see that all of those proofing errors have been removed. So let's just show that we can actually enhance this a bit more. Let's say that we also wanted to remove comments from that same document. We can integrate that right into this transform in a super easy fashion. I'll delete the test.docx and restore my version that has proofing errors in it. So here's my example. Let's put a comment in there. And now let's look at the markup again. And here we can see the comment range start, the comment reference element, and the comment range end element. Let's remove all of those in this same transform. This W class and all of the predefined XName objects are also part of the OpenXML Power Tools, and it's pretty convenient to have those classes involved here. The exact same thing is what we want here. Before we run this, I am going to make one more modification to our source document, which is I'm going to come up here and I am going to insert a text box up here. And I'm going to format this text box. I'll say I want it to be square. I'm also going to put something in there that will contain some proofing errors. So I'll save that document, and let me show you how that impacts our markup. I'll drag test.docx onto Visual Studio, and here we can see, here's our markup for that text box. It actually happens in a drawing object, and if we keep on dropping down here, eventually we get down here into this TXBX content element, and underneath there we have some word processing paragraph elements, and underneath that we finally get down here and we can see that we have some proofing error elements. So in one particular case, the proofing error elements are a child of the paragraph, and in other cases they're all the way down in here at this deeper level in the hierarchy where they are descendants of the TXBX content element. And because of our recursive approach, our code will work without modification. I'll run the code and it runs very quickly as expected. And now if we look inside of our document, we can see we've removed proofing errors both in the main body of the document and in that text box. And you can also see that those comment elements have been removed. This is the whole approach that I used in the markup simplifier code that is part of Power Tools for OpenXML. You may find it of interest to go take a look at that example code. At this point in time, it will be much easier for you to read that code. I've covered the identity transform, I've covered replacing an element with a different element, and I've covered removing an element. In the next screencast, I'm going to show how you do transformations on attributes. One aspect of word processing ML is that in every paragraph there are these RSID attributes, and these RSID attributes are there to enable a scenario of merging two documents together. And if we're not interested in that, we may want to remove those RSID attributes so that we can make the markup easier to read. This is something we might do if we are showing markup for educational purposes. So in that screencast, I'm going to write a transform that removes those RSID attributes. So until next time,